Hey there and welcome back. Today I want to make a device that can measure the distance digitally. And to do so, I wanted to start today with an ultrasonic sensor. And today I'm going to use the HC-SR04 and a little display which is called GM009605. And which has a resolution of 128 times 64 pixels. And an Arduino Uno. The first step is to connect the Arduino Uno with the computer. Then you can connect the display with the Arduino, which is the VCC of the display to the 3.3 volts, the SDA port to the SDA port, which is the data for the screen, then the SCL port to the SCL port of the Arduino Uno, which is the clock for the screen, and ground to ground. Then I've built a little Lego contraption so that it is better visible for the camera. The first library I used is the Hello World sketch from the U8glib library. Then if you want to use this library, you need to search a little bit in the web what's the comment you need to use for the screen. For me it was U8glib, then a number, and then the resolution and the specification of the ports. So just look it up, and if you don't find anything, you can try and error uncomment and comment all these comments given in the example sketch. But because there was a lot of flickering and the library took a lot of resources, I wanted to use another one, and luckily there exists a second generation which is called U8G2. There I needed another comment, which is the one I'm blending in right now, and just again trial and error, and you'll find that one out. The next step is to connect the ultrasonic sensor to the board. To do so, you need to connect the VCC to the 5 volt pin of the Arduino, ground to ground, echo to pin 4 or whatever you specify, and trigger to pin 3 or again whatever you specify. Then you can install the library called NewPing, and with the example sketch you can get the first values in centimeters or inches in whatever you like. Though combining these two libraries, the U8G2 and the NewPing, it appeared that it was a little bit too resource heavy, and there was a warning that it might be unstable. Luckily, there is another library which is called U8X8, which is a little bit lesser on the resources, and which worked out pretty well for me, and I could increase the font so that it is better visible again for the camera. As a little improvement to the example sketch, I recognized that not everything of the screen gets updated when another number is printed to the display. And to go around that, you can call the clear display method, which gets you this nice little animation. And then I recognized that it was a little bit too often the clear display function, and it was a little bit laggy and heavy. So you just want to clear the display and print a new number when your module returns another value than which is currently displayed. Next, to get the board away from a PC, you can plug in an external power source, and I've used, for example, a 9 volt block, and you connect the plus port to the VIN, voltage in port of the board, and ground to ground. Now let's figure out how accurate the ultrasonic sensor is. All in all, it is quite good, especially for near distances. However, because of the way it works, which we're going to talk about later, it has problems with glossy surfaces which are roughly angled at 45 degrees, because then it returns a wrong value, or when it is more or less, it just doesn't return any value. The second problem is that the ultrasonic sensor has a max distance, which is in this case 3 meters, so it's a little short for a measuring device. And when you see the number 0, you aren't quite sure whether it is I'm not measuring anything, or whether it is that something is blocking the module. For example, a 45-degree object. Now, to understand why it has a problem with these objects, and you can see that it is way more than it would be on the ruler, but what it actually does, it adds up the distance between the module, the plane, and from the plane to the camera lens. And this is because of the way it functions. Because what it does, it sends out a high frequency wave and then waits until it returns. And with this 45-degree plane, it sends out the wave, then it hits the 45-degree object, which then redirects the wave up. And on the upside, we have, for example, something which returns this wave. Then from the object, it is again reflected with 45 degrees, and then it returns to the module. And that's why you get the distance added to the top end of the ruler. So now we've covered that a UV sensor is good for short distances, but not so good for a measuring device. I hope you enjoyed. If you did, then please leave a like or comment and subscribe. Stay curious, and bye.